Hello student, how are you all? Good afternoon beta. Good afternoon. So, how you are doing? Yes student, how are you all? Great. So have you all taken lunch? Yes, I am also good student. Thank you for asking. Yes. So, remembered what we have learned in the previous classes? So just let's recall what we have learned. Yes. About contact forces and its type, okay, and about muscular force and friction force, okay. Yes, so students, just like contact forces, there are some non-contact forces are also there, okay. And today that is what I'm going to tell you about the contact forces, about non-contact forces. Where do you think so far, student? Where do you think so that you can see non-contact forces in your surrounding? Yes, where you feel that there is no contact forces are applying there. Yes. Anything? No. Yes. Okay, fine, no problem. Now I will. What do you have to do, student? You have to just go to your room or ask from your mother if there is any magnet. I'm giving you all 1 minute. Just go and bring magnet, right? Like this. I have one magnet in my hand. Just go. Giving you 1 minute. Just go and bring quickly one magnet. Sorry, two magnet, right? Yes. Please go and bring. Yes, Bittu, please go fast. We don't have much time, right? And we don't waste our time. Just go and quickly bring. Good. All have bring magnet. Yes. Now you have to perform activity, student. Okay. What you have to do? You have to force. You have to take a magnet in your hand. Okay. Yes. Now bring another magnet in your another hand. And now what you have to do? You have to bring it closer towards the one on the surface, right? Yes, but you have to take care that the both magnets not touch each other like this. That shouldn't be happen. You need to bring a bit closer. That's it. But don't forget that we should not that should not be touched, right? Touch, right? Yes, student. What you have observed? Yes, what you have observed? Yes. Again do. Yes. So as soon as the yes, Suman. Yes, good. So as soon as the magnet was brought closer to the other one, the magnet that was on the surface started moving towards the other magnet. Good, very good. Yes, Suman was right. Suman is right that as soon as we bring bit closer to that both magnet, they both attract to each other, right? One try to get the other magnet, right? Yes. So the magnet that was on the surface started moving towards the other magnet. They both get attracted and stuck with each other like this, right? Yes, like this. Yes. So now student, if we bring the other end of the magnet towards the one on the surface, then now what will happen, student? Yes. See, this is the magnet, and if I will bring the other one to the surface of the other magnet, then what will happen? Yes, come on. Yes, the magnet on the surface moved afar and the magnet repelled with each other. Good, Dipali Puri, Sweta, Swati, Suman. Good. Yes. So today's our topic is about magnetic force. All right. These are the magnetic force which you have seen just now. So these are the magnetic force. So the attraction or repulsion between objects can be seen as another form of pull or push, right? You must have seen that how these two magnets attracted like to pull each other, right? And when the surface, and I try to do this and the to try to keep the magnets from the surface, then they push each other, right? So the attraction or repulsion between objects can be seen as another form of pull or push. A magnet can exert a force on another magnet without being in contact with it. Yes, you have seen, like without being in contact in it also we can bring a force. A magnet can exert a force on another magnet without being in contact with it. Now, the force exerted by a magnet is an example of, yes, is an example of non-contact force. Good student, good class. So similarly, the force exerted by a magnet on a piece of iron is also a non-contact force. I have also a piece of iron. See, this is the piece of iron, and if I will bring a bit closer to it, then how it attracts, right? So yes, see, the force exerted by a magnet on a piece of iron is also a non-contact force. Yes. Now student, how does a compass work? How does a compass work? How do you think so that this compass work? Yes. Sneha, please answer. How does a compass work? Come on, quickly respond. Okay, compass works by detecting and responding. Alright, compass helps in solving maths. Okay, Suman, good. Yes, Swati. Compass work by detecting and responding to the Earth's natural magnetic fields. Yes. And what the others? Part? Yes. Do you know that compass tells direction? Yes. Yes, so compass is a tool for determining direction by means of a magnetic needle pointing north. Determining direction is possible by measuring the angle between the objects, right? Yes. So compass needle always points to magnetic north, which is different than true north. So in this way, compass work. Good. Now, two objects repel each other. This repulsion could be due to frictional force, muscular force, magnetic force, none of these. Right? Two objects repel each other. This repulsion could be due to frictional force, muscular force, magnetic force, none of these. Yes? Please respond, student. Quickly respond. Magnetic force. Very good. Good class. Now, have you ever rubbed, student, on a scale This is a scale. Have you ever played by rubbing your hair? This is the scale in here and putting in a piece of paper. Have you ever done it? So just go and bring, just remember that game once again. So just go and bring the scale and also a piece of paper with you, right? I'm giving you 30 seconds. Just go and bring scale and piece of paper. Yes, please go. Yes, done. Yes, now what you have to do, you have to rub this scale in your hair, and as this is steel one, I don't have plastic scale, so that is why it's not happening in your side. If you have a plastic scale, then please do it. Yes, the paper gets attracted towards it, right? When they bring small particles of paper towards the scale, the paper gets attracted towards it, right, Suman? Yes. Now please observe this video very carefully.
Kissing me, close your eyes and
take a balloon, inflate it. Now tie up the open end with the help of a thread. Take a white paper, cut it into small pieces. Place the small paper pieces on the table. Take a balloon and rub it with another paper. Now bring the balloon near the pieces of paper. Observe the changes. In this activity, we observe that there is an attraction between the balloon and the paper bits, even though the balloon is some distance away. Finally, we say that when the balloon is rubbed with a paper, it acquires an electrostatic charge on its surface. The balloon is now...
Yes, student. So what you have observed in this video? Yes. Quickly respond. That when the balloon was rubbed with a sheet of paper and brought near the particles of paper, the balloon paper particles were attracted to each other. Good, Sonam. Yes. What are the other observations done by student? Yes, the Palipuri, Ramesh, Sandhya, Swati, Sneha, Bittu. Yes, quickly come up and tell your observation of this video. They have, okay, good, Sneha. Good Ramesh, Suman, very good. So you have seen that a balloon was rubbed with a sheet of paper, and when they brought near the particles of the paper, the balloon and the paper particles were attracted to each other. And why this has happened, student? Because of electrostatic force. Good student. Now, during the change of state of motion of the paper particles, they were in contact with each other, student? Yes or no? Have you seen that when you have done when you have rubbed the scale on the hair, and when you have when you have bring bit closer to the paper and scale, then do you need to do contact, to make contact between scale and paper? Do you have done like this? Yes or no? And even in video, have you seen that the balloon and paper, that man have to contact with each other? Yes or no? No, right? Yes. So I'm going to talk about electrostatic force now. Okay. So when the balloon is rubbed with the paper, it acquires an electrostatic force or charge on its surface. Alright? When a balloon is rubbed with a paper, it acquires an electrostatic charge on its surface. The balloon is now a charged body. When it is brought near the bits of the paper, the pieces acquire opposite charge and rise and cling to the balloon, because the balloon acquires opposite charges and rise and cling to the balloon. Okay, the force exerted by a charged body on another charged or uncharged body is known as electrostatic force. What is electrostatic force, student? The force exerted by a charged body on another charged or uncharged body is known as electrostatic force. This force comes into play even when the bodies are not in contact, right? You have seen that. The electrostatic force, therefore, is another example of non-contact force, right? True? Yes. Now, why does a plastic comb carry charge in it and attract the object of opposite charge, whereas a metallic comb does not? You have seen, like, the metallic scale does not, but plastic scale can. The same way plastic comb can, but metallic comb does not. Why? What's the reason behind that, student? Okay, good point, Swati. Good. Yes, good. Now, electrostatic force comes into play even when the bodies are not in contact. True or false, student? Electrostatic force comes into play even when the bodies are not in contact. Is it true or false? Yes. Quickly respond. True. Okay. Why, Suman, you have written false? Okay, by mistake. Yes, it's true. Now, student, where the fruits and vegetables fall to after, yes, where the fruits and vegetables fall to after detaching from the tree. Yes, from the tree when it detach, where it falls? Yes, ground. Okay. Okay, fine. Yes. Yes, so they fall on the ground. Now, when you throw a ball upward, yes, just give me a second, student. Yes. When you throw a ball, right, upward, or yes, when you throw a ball upward with great speed, what happened to the ball after some time? Yes, look. If I throw the ball after with a great speed, then what happened with that ball after some time? Yes, you have seen that how ball comes to the ground, right? Yes. And if I throw the pen to the upward, then see, again it will come to the ground, right? Yes. Now, bring one coin, student. I'm giving you 30 seconds. Just bring, okay? Yes, go and bring one coin, any kind of coin, student. Suman. Okay, you have an American coin. Okay, like this, just go and bring. We'll do one activity. Okay, quickly came. Okay, now what you have to do, you have to throw a coin like this. Yes, like this, or throw a pen in upward direction, right? So what happened to the coin and pen after it was thrown, student? Yes, all have done. And what are your observations, student? Yes, that the coin or pen fell down, right? Good. Good, Suman. Good classes. Good. Very good. Yes. Now, so if the state of motion of the coin or ball changed, do you have noticed that the state of the motion of pen or a coin changed? Yes. Okay. Now, so if there was any kind of contact of pen or coin with anything, no, yes. So in this way, so this I'm going to start talk you about gravitational force. Okay, yes. So objects or things fall towards the earth because it pulls them. This force is called the force of gravity or just gravity. This is an attractive force. The force of gravity acts on all the objects. The force of gravity acts on all of us all the time. Okay? Without our being aware of it. So student, every time we are facing or we are getting gravitational force without being aware of it, water begins to flow towards the ground as soon as we open a tap. Water in river flows downward due to the force of gravity. Gravity is not a property of the earth alone. In fact, every object in the universe, whether small, large, exerts a force on every other object. This force is known as gravitational force. Okay, student? Yes. Now, tell me, what if there was no gravitational force? Yes. What if there was no gravitational force on the earth? Then no, nothing will happen, right? Good. Just now I have told you that in every part of every time of life there is some contact force, there is gravitational forces. If I want to drink water from the tap, then also there is a gravitational force. If I throw the pen upward, or if fruits falling down from the tree, then also we are there is a gravitational force. If there was no gravitational force, we are not able to yes, good, Suman. Yes, that is what I was going to tell, that we are not straight, right? We are not able to sit, we are not able to stand because we are always in the air. Yes, because of the gravitational force only we are able to sit here, we are able to stand here, right? Yes. Now, leaves fall down on the ground due to electrostatic force, magnetic force, gravitational force, muscular force. Yes. Gravitational force. Very quickly to answer. Good. Now, let's capture this class. We learned about non-contact force and its type, non-contact force along with its type, and different types about magnetic, electrostatic, gravitational forces. Then we have discussed about the action of magnetic force, electrostatic force, gravitational force, right? And different types of contact forces with real life examples. This is your homework. You have to name the forces acting on a plastic bucket containing water held above ground level in your hand. You have to discuss why the forces acting on the bucket do not bring a change in its state of motion. Then a rocket has been fired upwards to launch a satellite in its orbit. And you have to name the two forces acting on the rocket immediately after leaving the launching pad. Now, another activity, observe your surroundings and write down the observation where you can see electrostatic force. Okay, student? Have a very wonderful day. We will meet in the next class. Till then, bye-bye. Take care. Bye, student.